Hello, AP Chemistry students. This is Mrs. Altman. We are on video number 36, Acid-Base Equilibria Part 5. Here are our objectives for today's video. Pause here. You don't need to draw the picture. All right, so to answer the first question, you could look at it this a couple different ways. You could just see which one has the equivalence point at 7, and you'd see that it's the black line. That would be probably the easiest way to do that, and that the red one must be acetic acid because its equivalence point is above 7. But I want to point out a couple of other differences. The first difference, and if you take a look up here, we can see that the concentrations are the same for the acids at the start of the titration. The initial concentration is much lower for HCl than acetic acid, which makes sense because HCl is a strong acid and acetic acid is a weak acid. We're also seeing more of what's called a buffering region with the acetic acid. Meaning that there is a region where there's just minimal changes of pH before the pH jumps right up. Whereas there's not really, it's 1 and then maybe like 1.10. So there's we're seeing that the pH pretty much jumps right from like 1.5 to like 12. And that's just something you can expect to see with a strong acid being titrated with a strong base. Pause here. Right, so we've worked with pH indicators before, phenolphthalein and thymolphthalein. These are just weak acids or weak bases that have a different color when they're in their HA versus their A- form. And this color change is going to happen when the pH exceeds the pKa. So with the phenolphthalein and thymolphthalein, the pKa is right around 7, which is why we can use it for experiments with acids and bases. Pause here. You do not need to draw the picture. Right, so this is asking for Kb, which is a little bit different than what we've done before. What I do know is that at the halfway point, the pH is equal to the pKa. So let's take a look and find where the halfway point is. So the halfway point, I'm going to estimate as being, let's say, 9.2. Again, this is a kind of rough estimate. So the pH is 9.2 at the halfway point. What that means is that the pKa is equal to 9.2. And then there's a couple of different ways that I could convert this to Kb. I'm going to go with doing pKa plus pKb is equal to 14, but there's other ways to do this as well. And then to get Kb, it's just 10 to the negative pKb. So I get 1.6 times 10 to the negative 5th is my Kb value. This value makes sense to me. First off, I know that this is a base, so I'm expecting it to have a Kb that's less than 10 to the that's greater than 10 to the negative 7th. So that makes sense to me. I actually happen to know this Kb value off the top of my head, and I know that it's pretty close to that, though I wouldn't expect for you to know that off the top of your head. Great. Here are the problems for this video. Thank you so much for watching and have a great night.